All right, everyone, we're back, and this time we're going to go over Marplot. So, again, I moved all my icons over here so you can just kind of see them separate. So, we're going to open Marplot here. Marplot, for whatever reason, well, this newer version's a little better, but it kind of uploads slowly. On my computer once in a while. So I think it's the base maps that take so much loading. So let me zoom out here. So as you can see, it's really somewhat of a GIS mapping program. And I'm not going to get too far into the weeds on Marplot because I'm not going to go over layers or anything like that. I just really, what I want to show you is the interface between Marplot and Aloha because I think it's really, really cool. So if you look over here on the right hand side, you'll see a menu. It's got, boxes and legends first, and again, maybe someday we can get into this stuff and the layers, but right now I'm just going to minimize those. And really all I want you to do is look at the base map. So the base maps, you have your choice between Google, Esri, and then there's a couple other ones down here, like there's NOAA nautical charts and there's OpenStreetMap. I've been using Esri. I don't know if I have a preference, but you can definitely switch them back and forth. I want to say the reason I was kind of using Esri is because Google was taking longer to load. But it really, whatever your preference is, get in there and play around with them. Now, the one thing is this does download some of the base maps, but it also seems to help if you're on Wi-Fi. And it runs a little faster because it can pull the maps as it needs to, if that makes sense. But you can see here, we got our map going. I already had it on Fairbanks, so that was pretty handy. And what I'm going to do is I'm going to use actually my place of work. And let me get into Esri Satellite. That's kind of, hey, come on, Esri. For what? There we go. So that must be a layer that's not satellite, maybe. I don't know. It took a minute to load. So what I'm going to do is I'm going to go to my place of work, which is right here, Alaska West Express. And again, we're running a rail car, a chlorine rail car. So I'm going to show you what that looks like. I have no idea why it keeps popping off of the satellite. Now, the one thing I want to show you real quick is I had this little blinking purple cross. If you'll notice, wherever you click your mouse, it's going to put that purple cross. And that's important to understand because that is the threat point. And when you look up here, you have Aloha and CAMEO buttons. Source point, not threat point. Source point. When you click that, it says set source point at click point. That's important because that is going to determine where I'm going to switch to Google Satellite real quick, where we overlay our plume. Now, one thing you got to understand is the inputs that you do in Aloha will read into Marplot. All right, y'all, do you see how it keeps getting out of the satellite image and going to a topo image? That is not me. That's not anything I'm doing. For whatever reason, it keeps doing that on its own, and I don't know why. Honestly, I downloaded this right before I started this video, or actually last week, but I don't know if that's a bug in the new version, but it keeps going away from satellite and giving me the topo. Now, typically, I love topo, right? I'm a topo guy. I spent 10 years in the Army reading topo maps and running compasses off of them and doing land navigation. Okay, that was all on its own. It just switched all on its own, and I'm not sure why. It could be something I'm doing, but usually I just click over here and it will switch whatever mapping program I want. So I don't know why it's doing that, but we'll work through it anyway. But for what we got to do, I really like the satellite images because it shows buildings and all that stuff. And when you look at Alaska West, and I think I said this on Wiser, when I put in our address, which is 1075 Cinch Street, it does not know, it knows really, okay, that's the address of this property. There's a spill or a release on there somewhere. But what it's not giving me is, hey, that release is over here in our rail yard where they push the rail car in, So, it's important to be able to use satellite, I think. So we'll just call that our threat zone, actually. I just put my source point right there. Now, if you remember in Aloha, we modeled this plume, right? And so we had wind coming out of the east. If you look at display, it's going to show you, all of your different AEGLs. Still not a lot of good data here because we don't know what this looks like. So what I'm going to do is in Marplot, I'm going to, and let me center this a little bit, and it'll probably auto zoom on me here because I think this is going to be a giant plume. But what I do is I come up here to my Aloha button and I have the little drop down menu and I say set source point at click point. And if I click on that, yep, it auto zoomed out. Boom. Now it overlaid my plume on my map. And again, this is really handy data, right? So if we scroll in and kind of look at it, just to kind of see what's going on, you can see our different AEGLs here. Now, you can do something kind of cool with this. If you click on that AEGL, it's going to tell you how big it is, essentially, right? So it's got a perimeter of 22,363 feet. It tells you the area in square miles. Here's some of the information, as far as what we put in. And then it's telling you each AEGL, how big they are. So when we look at this, actually, let me close that little guy out. When we look at these different AEGLs, it's really going to tell us, hey, what do we need to concentrate on? The people in the yellow, well, they really should be okay for 60 minutes, right? So we maybe not want to concentrate on them, or at least not concentrate resources or bodies on them. Maybe we just do a reverse 911 or whatever and trying to contact them, tell them to shelter in place, or actually we could tell those folks to evacuate, and it should be fairly safe as far as the chemical is concerned. So maybe what we need to do is, concentrate on this orange section here and look at those folks and doing something for them. So really this is, to help us manage our incident, if you will. So there is consensus data in here. So if I want to know the entire population that this has affected, I click on that, and then if I go up here and say, hey, I want to get the population with inside the selected area, well, this is an industrial area, so it's not showing any population, but it would tell us how many people are in there and how many housing units. And of course, it's based on consensus data, and the data that's in here is from 2010, so but it gives us an idea, and in this one, this is a pretty good example. It's like, oh my gosh, who do we have here? Well, no one's living out here. So if this spill occurred, at midnight on a weekday, we should really expect no people in our threat area unless there's a business that's doing 24-hour operations or something like that. But if you were to overlay, somewhere else in Fairbanks, like, over here, then obviously there's a bunch of population there that we would have to consider. So there you go, you guys. It's that easy. It's really easy to overlay a threat. What's not easy? Oh, let me back up. So this yellow line, because I didn't talk about it in Aloha on the plume model, but this yellow line, really what it shows you is, hey, if the wind shifts a little bit, this is what we could expect. So really, when you look at doing a reverse 911 or something like that, you would want to pay attention to, anything that would be between the actual threat area and this yellow border, because those are potential threat areas. And that's what that yellow line is. It's just to take into account some wind shifting, right? You could also see that the plume model's back a little bit. Of course, chlorine is a high vapor pressure product, so if it's releasing out of this rail car, it's not just automatically going downwind. So if you look, this is a pretty good hot zone right here, right? So when we do our scene control, we can actually use this to help determine the actual hot zone. And you do that by looking at the distance between your threat point, or your source rather, and the edge of this plume. So how do you know how big that is? Well, if you look up here, we have a little yardstick. So we click the yardstick, and if I want to measure this, it just says, hey, click to drag. And when I drag this, it makes a circle. And then when I look up here, it's like, all right, the perimeter, so the distance of the entire circle, or across the circle, the perimeter is the distance around the circle. I should go back and take some geometry classes, I guess. The radius is what we're interested in. So the radius here, so the distance from our source to the edge of what we would call our hot zone, is 104 feet. And we could be conservative. We could actually put it, farther than that back here somewhere. But the little measurement tool is pretty cool too. So it's about it. It's about all I wanted to show you guys in Marplot. This is a very powerful tool. There's some stuff in here that I've used in the past, but I would be really rusty because I don't use it all that much. But yeah, it's good stuff, right? Oh, what I was going to say, though, was changing. Let's say we had a wind shift, and now it's blowing from the southeast. It's pretty much impossible to change this without going into, come on, I need my pointer now. Without going into Aloha, and that's what you'd have to do, is you'd have to come into Aloha, close this out, go back to your setup setup, atmospheric, and you'd actually have to change your wind. And so we got our wind speed. So now we're going to say, hey, it's coming out of the southeast. And we click OK. And if none of this data changed, we just OK through that. And then we would have to come back to Marplot. Marplot. And set our source there. So let's get our click point going. And then readjust our plume, and hopefully it does it for me. Come on, Aloha. Oh, I think maybe I clicked too much there. All right, it is really, okay, delete all Aloha objects. All right, y'all. So I'm looking a little derpy right now. Let's close that guy out, get rid of that. So I'm trying to just Aloha source point. So, yeah, for whatever reason, it's not rerunning the model. So I'll tell you what I would probably do at this point. I would close that guy out, minimize this, reopen it. It's somewhat intuitive. It should come back to roughly the same area I was. Yep. So that's kind of cool, right? And so I set my threat point again, or my source point rather. Huh. It is not. I think I'm forgetting something. Display threat zone. You know what? I think you have to do that. I think you have to go in and display the threat zone. Yep, that's what I was doing. All right, so little derp moment there for me. You know, like I said, I'm not a power user with these programs at all. So the reason it would not rerun the model again is I had to go back in here to Aloha and go to the display and threat zone, and then when it ran the model, that's when it would now talk to Marplot. So there you go. We're all learning. Now, like I said, I'm not a power user at this stuff at all. So that's a lesson on me. I probably wouldn't have had to have closed out Marplot. So that is the plume modeling in Marplot. When we come back, the other thing I will show you guys is the building to show you, you know, how to interact with Marplot and Aloha. So if you tell someone to shelter in place, so you know roughly how long it would take for the concentration inside a building to equalize with the outside.